Hi, welcome back. Let us now look at provisioning an autonomous database in Oracle Cloud Infrastructure. Provisioning an autonomous database requires only answers to 7 simple questions. You have to pick a data center region, you have to name the database, you have to select how many CPU cores you're going to allocate to this database, and how much storage capacity you need. And also then select the license type, whether you want to enable autoscaling or not, and give a password for the admin account. Once you do this and click on Create Autonomous Database, a new service will be created in a few minutes, and after that the database is open and ready for connections. Let us now look at the autoscaling functionality of Autonomous Database. Autoscaling allows Autonomous Database to automatically increase the number of CPU cores by up to 3 times the assigned CPU core count value, depending on demand for processing. The autoscaling feature reduces the number of CPU cores when additional cores are not needed. You can enable or disable autoscaling at any time. For billing purposes, the database service determines the average number of CPUs used per hour. So on the slide in the right side of the screen, you'll see that this particular service has automatically scaled up OCPUs up when there is a demand for more computing power, and then scales it down once the demand goes down. Let us now look at securing Oracle Autonomous Database. The Autonomous Database stores all data in encrypted format in the Oracle database. Only authenticated users and applications can access the data when they connect to the database. Database clients use SSL/TLS 1.2 encrypted and mutually authenticated connections. This ensures that there is no unauthorized access to the Autonomous Database Cloud, and that communications between the client and server are fully encrypted and cannot be intercepted or altered. Certificate-based authentication uses an encrypted key stored in a wallet on both the client and the server. The key on the client must match the key on the server to make a connection. A wallet contains a collection of files, including the key and other information needed to connect to your database service in the Autonomous Database Cloud. You can specify IP addresses allowed to access the Autonomous Database using the Access Control List. This Access Control List will block all IP addresses that are not in the list from accessing the Autonomous Database. So let us now look at this example here. So we have an Autonomous Database deployed in this example, and this database is being accessed from a private subnet as well as from a public subnet on Oracle Cloud Infrastructure, and it's also being accessed by a server over the public internet. So how you would secure this database is you can use the access control list to specify the CIDR block. Basically, this is needed if you are accessing the Autonomous Database from the server running on a private subnet, and the access happens over the service gateway. And to make things simple, like you can also use a NAT gateway and specify the public IP of the NAT gateway. This will also be another option for connecting to the Autonomous Database from a private subnet. And for connections to autonomous database from a compute instance running on a public subnet of Oracle Cloud Infrastructure, you will just take the public IP and you'll add it to the access control list. And finally, like for the access over the public internet from a computer running on premises, you will grab the public IP and you will add it into this access control list. Once the access control list is populated, if a user tries to access autonomous database service will look at the access control list and determine whether this particular connection is valid or not. If the IP address doesn't fall in this list, then the connection gets rejected. And if it matches one of these entries, the connection goes through. And also the customers or the user needs to have the wallet and they need to have the user ID and password to access the autonomous database. So security is pretty slick here when it comes to accessing autonomous database. Let us now look at troubleshooting connectivity issues. You need to ensure that the access control list for autonomous database has the necessary entries for CIDR block ranges and IP addresses as your use case dictates. When connecting to autonomous database from a client computer behind a firewall, the firewall must permit the use of the port specified in the database connection when connecting to the servers in the connection. The default port number for autonomous data warehouse is 1522. Your firewall must allow access to servers within the .oraclecloud.com domain using port 1522. When connecting to autonomous database from a server running on a private subnet, ensure that you have a service gateway or NAT gateway attached to the VCN. The route table for the subnet needs to have the appropriate routing rules for the service gateway or NAT gateway. The security list for the subnet will need to have the right egress rules. For connections originating from a server running on a public subnet, ensure that route table and security lists are appropriately configured. We will now learn how to scale your autonomous database in Oracle Cloud Infrastructure. You can always scale your database on demand without tedious manual steps. You can independently scale compute or storage, and this resizing occurs instantly with the database fully online. Memory, I/O bandwidth, and concurrency scales linearly with the CPU. You can close your database to save money when not used, and you can restart instantly. As far as monitoring your database goes, you have a couple of choices. You can use the Service Console based monitoring, where you have a simplified monitoring capability using the web-based Service Console. You can look at historical and real-time database and CPU utilization. You can do real-time SQL monitoring to monitor running and pass SQL statements. You can also look at the CPU allocation chart to view number of CPUs utilized by the service, and this can be pretty handy if you want to figure out how you're getting billed for your CPU utilization for the autonomous database service. We also have the Performance Hub based monitoring. This is natively integrated in the OCI console and available via single click from the autonomous database detail page. And this has active session history analytics and also real-time SQL monitoring capability. We will now look at backup and recovery for the Autonomous Database Cloud service. Autonomous Database Cloud automatically backs up your database for you. The retention period for backups is 60 days. You can restore and recover your database to any point in time in this retention period. Autonomous Database Cloud automatic backups provide weekly full backups and daily incremental backups. Manual backups for your Autonomous Database Cloud is not needed, but you can do manual backups using the Cloud Console if you want to take backups before any major changes, for example, before ETL processing, to make restore and recovery faster. The manual backups are put in your Cloud Object Storage bucket. When you initiate a point-in-time recovery, Autonomous Database Cloud decides which backup to use for faster recovery. You can initiate recovery for your Autonomous Database Cloud database using the Cloud Console. Autonomous Database Cloud automatically restores and recovers your database to the point in time you specify. Network access control lists are stored in the database with other database metadata. If the database is restored to a point in time, the network ACLs are reverted back to the list as of that point in time. Let us now look at the cloning feature of Autonomous Database Cloud. Autonomous Database provides cloning where you can choose to clone either the full database or only the database metadata. When you do a full clone, it creates a new database with the source database's data and metadata. If you choose to do a metadata clone, a new database is created with the source database's metadata without the data. When creating a full clone database, the minimum storage that you can specify is the source database's actual use space rounded to the next terabyte. You can only clone an autonomous database instance to the same tenancy and the same region as the source database. During the provisioning for either a full clone or a metadata clone, the optimizer statistics are copied from the source database to the clone database. The following applies for optimizer statistics for tables in a clone database. When you do a full clone, loads into tables behave the same as loading into a table with statistics already in place. When you do a metadata clone, the first load into a table after the clone clears the statistics for that table and updates the statistics with the new load. In this slide, you see screenshots for cloning in Autonomous Database. So you can select a clone type of full clone or metadata clone, and you specify which compartment you want to clone to. Select the source database name and provide a display name and database name for the target database, and also specify the CPU core count and the storage, as well as click on whether you want to do auto scaling for your database or not, and then specify the admin password. And finally, you will select a license type of bring your own license or license included model, and then click on Create Autonomous Database Cloud. Let us now look at the predefined services which are used for accessing Autonomous Data Warehouse. The three predefined database services are identifiable as high, medium, and low, and this gives you a choice of performance and concurrency for Autonomous Data Warehouse. The first service is high, which gives the highest resources and the lowest concurrency, and queries run in parallel when connected using this service. The second service is medium. When a user connects to the Autonomous Data Warehouse using this service, they get lesser resources compared to high, but it has higher concurrency and queries run in parallel here. And the last one here is the low service. For connections to the Autonomous Data Warehouse using this service, they will get the least number of resources but the highest concurrency, and queries run serially here. So on the slide in the right side of the page, you'll see an example for a database with 16 OCPUs. It can have 3 connections using the high service, 20 using medium, and 32 using low. And the maximum idle time for high and medium service is 5 minutes. So basically, if somebody connects to the data warehouse using high or medium service and the session remains idle for 5 minutes, then this session gets disconnected after 5 minutes. Note that when connecting for replication purposes, we recommend that customers use the low database service name. For example, if you want to use Oracle Golden Gate for data replication, then you need to configure the database connectivity parameter for Golden Gate to use the low database service. Let's now look at the predefined services for autonomous transaction processing connectivity. There are 5 predefined database services controlling priority and parallelism. There are different services defined for transactions and reporting. As you saw in the previous slide, we have the same kind of services, namely high, medium, and low, with the similar characteristics as the autonomous data warehouse. In addition to these 3 services, we also have TP urgent and TP service. These 2 services, TP urgent and TP, are for transaction processing, and the other 3, high, medium, and low, can be used for reporting or batch processing. Also note that when you use high and medium, the operations run in parallel and are subject to queuing, and there is no parallelism when you use low or TP service. Let's quickly look at the autonomous database dedicated service offering in Oracle Cloud Infrastructure. The autonomous dedicated database service provides a private database cloud running on dedicated Exadata infrastructure in the public cloud. It has multiple levels of isolation, which protects you from noisy or hostile neighbors. Customizable operational policies give you control of provisioning, software updates, availability, and density. This slide shows you the physical characteristics and constraints. As it stands now, a quarter rack X7 Exadata infrastructure has 2 servers, 92 OCPU with 1.44 terabytes of RAM. It has 3 storage servers, which will give you 76.8 terabytes of flash and 107 terabytes of disk space. And there is 1 cluster per quarter rack, and you can have a maximum of 4 autonomous container databases per cluster. And if you choose to have high availability SLA for your autonomous databases, you can have a maximum of 100 databases. Or if you have extreme availability SLA for your autonomous database, you can have a maximum of 25 databases. Here's a quick look at the high-level deployment flow for autonomous transaction processing dedicated. The same thing holds good for autonomous data warehouse dedicated as well. The first step is to create a virtual cloud network, and then you will provision autonomous Exadata infrastructure. And once that is done, you will create autonomous container database. And then finally, you will create your autonomous database. Let us now look at security functionality in autonomous transaction processing dedicated. This applies to autonomous data warehouse dedicated as well. Databases are always encrypted in this service, and you get a reduced attack surface. We automatically protect the customer data from Oracle operations staff. we use Database Vault's new Operations Control feature. Oracle automatically applies security updates for the entire stack. We also apply quarterly or off-cycle patches for high-impact security vulnerabilities. Customers can separately use Database Vault for their own user data isolation. In the course of these lessons, you learned about the difference in autonomous database and DB system cloud offerings in Oracle Cloud Infrastructure. You learned the features of autonomous data warehouse cloud, serverless and dedicated, as well as transaction processing, serverless and dedicated. And you also learned how to deploy, use and manage autonomous database. Here are some additional resources that you can use to get more information on the autonomous data warehouse and transaction processing services. Thanks for watching this lesson.